EET 105, Chapter 3, Resistance. Resistance is the ability of a material to resist flow of electricity, like current flow. The formula for resistance is rho times L divided by A. Rho is the Greek letter rho, stands for resistivity. It's in circular milliohms per foot at temperature equal 20 C or centimeters versus circular milliohms per foot. Typically, we're going to use circular milliohms per foot. L is in length in feet or centimeters. A is the cross-sectional area in circular mils. 1 mil is a thousandth of an inch, or 0.001 inches, or in centimeters squared, if we're in metric system. The area for area is the diameter of the wire in mils squared. Okay, d mils here is the diameter of the wire in mils. R is the resistance in ohms. The symbol is omega. And G is the conductance in mhos, which is just the opposite. It's ohm rearranged, or in Siemens, which is the company I work for. And the formula for resistance is 1 over the conductance. Likewise, the conductance is 1 over R, or A divided by the quantity rho L. The inferred absolute temperature relationship, resistors change with temperature. So each material has Ti, which is the inferred temperature. It's in a table in the book. It would be table, let's see, 3.3. So if we look at table 3.3, this is table 3.3 here. So each material has a different inferred absolute temperature. Notice that these are all negative, okay? It's the temperature, I believe, that the resistance goes down to 0. So these are pretty cold temperatures. This is the formula. If you're given, let's say, T1 and R1, and then T2, you can figure out what R2 is. If you're given T1 and R1 and T2, you can figure out what R2 is. You know, just given any of the three, you could figure out what the fourth one is from this formula. It's just a proportion. And then going back to the circular mills, there's a table for that, table 3.2. It's American wire gauge AWG sizes. This can be found in the Uglies book. There's a book out there. It's a handbook called the Uglies book that I have, that I used to use a lot. It shows AWG. This is called 4/0, 3/0, 2/0, 1/0, and then 1, 2, 3, 4, all the way up to, they have up to 40. That's pretty small, but it gives you the area in circular mills. Let's say if 12 gauge wire, the area in circular mills is 6,529.9, and then the ohms per thousand feet at 20 degrees C. If you had 1,000 feet of that wire, it would be 1.588 ohms. So the bigger the wire, the more the area, and the better it conducts electricity. And then it also has maximum allowable current for RHW and insulation, which is a common insulation. I think THHN is actually more common, but so it tells you kind of like the ampacity of each wire. So if you go down to 12, it's 20 amps. 14 is 15 amps. If you had 4/0, it would be 230 amps. And there's actually higher sizes than this. It goes up to it's called millions of circular mills. It would be MCM. See how this is 211,000? 250 MCM would be 250, and then it goes on to 300, 350, 500, 750, and 1,000 MCM is the biggest I've ever seen.